moving over here, we should have a bunch of reduced Qs in our membrane, and they're all moving towards our complex 3. Complex 3 is going to go all the way through the membrane. Okay, this one's kind of I'm going to draw this one a little bigger because this has a lot of stuff going on it. Okay, this is complex 3. It goes all the way through the membrane, meaning that it is most likely going to be pumping protons. And so this one is called complex 3, or Q cytochrome C oxidoreductase. Okay. So within this complex, there is something called the Q cycle that's going to occur. Okay, complex 3, you get the Q cycle occurring. So you have a bunch of these reduced coenzyme Qs with 2 electrons on them. And the other part of the name is cytochrome C. So this is the complex where you get the passing of electrons from your coenzyme Q onto your cytochrome C. The issue with cytochrome C is that it only can carry 1 electron. So your Q will be left with 1 extra electron after it passes an electron to cytochrome C, and that generates a radical, which is why you need the Q cycle, because the Q cycle will get rid of radicals. Gets rid of Q, it can be like this or like this, they're equivalent, okay? Q radicals. And why don't we want radicals around? Because radicals are oxidative, they damage cells, they cause different proteins to be oxidized and become damaging. So how does this Q cycle work? So like I said, we have our first Q coming in. So it's reduced, right? We have our QH2, and we have a cytochrome C. So for the cytochrome C, we're going to get the donation of 1 electron to the cytochrome C. The donation of 1 electron from the cytochrome C allows the complex to pump 2 protons. But what we're left with after donating 1 electron is that radical that I was talking about. So we're going to have this Q radical. That dot is like the radical, and you'll see more about radicals when you see Dr. Olson's lecture. And so we still have 1 electron on this Q. Okay, this is the Q radical. This is the one we don't want to stick around. And so in order to get rid of this Q radical, you actually have to use another fully reduced coenzyme Q to get rid of it and donate another electron. So it's an endless cycle basically, and you need to provide enough reduced coenzyme Q to prevent the radical from being around for a long period of time, because the longer it's around, the more damage it can do to your cells. So this is the first coenzyme Q we use, right? Now we are going to be using another one. So we're going to be having this Q radical. It will actually get turned back into QH2, okay, because what do we have? This other Q comes in from the membrane, and it is here, and what it can do is it can donate 1 electron and make that not a radical again. So that's where we use our second coenzyme Q. But the problem is, again, what we're going to get is, where is this? We're going to get another cytochrome C. And this coenzyme Q is also going to donate an electron to the cytochrome C. And because the cytochrome C, that donation, we can again pump another 2 protons. So again, this complex also pumps a total of 4 protons, okay? Just like complex 1. So complex 1 and complex 3 also both pump 4 protons. But you guys, if you look at this, so what do we generate here now? We've donated 2 electrons, so what are we left with? We're left with a regular Q. And where did we use the regular Q? We use that in complex 1 and complex 2. So the first step, we generate the radical. The second step, we are getting rid of the radical and providing a fully oxidized coenzyme Q that can go back to complex 1 and complex 2 and pick up more electrons.